2, 5. So we took that 1 day detour where we just learned how to graph absolute value graphs. So that'll be utilized today. There's one other quick skill I need to refresh you guys on from Algebra 1, just because I don't want to stop every time and talk about it. So um, if I gave you that and said graph it, it's been a while. Would you guys remember what it's going to look like? Yeah. It's going to be a line, right? Where would we start, did you say? Right. So to graph a line, like, it's pretty easy. I'll just sketch it like you would. And I'm just going to go up 3 because of that, go up to like here. And then the slope is negative. So we know the line goes downhill, right? We don't want to commit the ultimate egregious sin. And since the slope is -0.5, it probably goes something like that. That's what it would look like when we have a rise and run ratio of 1 to 2. One down for every 2 to the right. So anyways, that's not really what I wanted to talk about. Do you guys remember what to do if I give you something like this? And I say graph it. Again, it's been a while because we did this in Algebra 1, but it has been a long time. Uh, Solve it first. Very good. I was hoping you'd say that. So remember, when we graph straight lines, we generally want to get y by itself first. So you're going to have to do this in 5 or 6 problems today. So I thought, let's tackle it real quick. What would we do first to get y by itself? Move the x. So we'd be left with -4y equals what? Perfect. -x because we moved it to the other side, and then the 8 is still positive. And then what would we do to finish? Divide by -4. And when you divide by -4, remember that the division happens, it's like distribution. It is literally distribution. And that's what happens is everybody gets the division and we're left with our graphable thing, which is what? 1/4 of x, just like that. So that's the expectation, is that you remember that, of course, that you carry that with you. You know how to get y by itself. Good. So let's get to it. So I got 4 examples for you. They should not take all too long. I'll give you a nice softball for a warm up. And I get to graph on this paper. Again, you'll just have to sketch. I'm sorry for that. So I have y equals 2 times the absolute value of x minus 2 minus 4. And then I have y equals x, thank you, minus 3. So we're graphing a system. We are not going to solve these algebraically. If anyone's interested, I can teach you how to do these algebraically. It's just you have to consider multiple scenarios, since the absolute value can be true for one thing if the stuff inside is a negative, and for another thing if the stuff inside is positive. So if anyone's interested, we can do that. But the standard mentions that we just have to know how to solve this type of system using graphing. So if you'd like, we can just call it good. But again, it's up to you. So let's graph either one. Which one do you want to graph first? Top one. Sure, let's get it out of the way. So the top one is the one with the red dots next to it. We've got an absolute value. What would we do first from yesterday? And where is the starting point? Perfect. So we know that from yesterday that we would travel to the right 2, 1, 2, and then down 1, 2, 3, 4, and we would put our starting point. And then what are the slopes of the arms? 2. So, I mean, to make an absolute value graph, you just leave from your vertex and then you just go up 2, out 1, right? And then you just keep doing that on the arms, and you do that enough times until you're sure that you've got enough points to connect the dots. So step 1 is to make this graph like such. Okay, and I maybe should make these a little longer. It just depends from one situation to the next. If we need more, then we can just put our rulers down and extend them. Like if the line that we're about to see, we can't really see the crossing. Like if we predict that it's going to happen a little further out, like if we can see later on that the crossing was going to occur like up here somewhere where that purple is, then we go, ooh, I got to have a little bit longer arm there. So you'll just figure that out as you go. But that should do. And then let's graph the other one, the one with the big green dots next to it. Where would we start that graph at? Down 3. So 1, 2, 3. And what's the slope? Up one, right one. So we're going to go up one, right one, up one, right one, up one, right one, up one, right one, and so on and so forth. And you can do a whole bunch, like you can skip. What I like to do with straight lines is just, save time and just do a bunch and one big jump. Like if someone said go up 2, right 3, I might go up 6, right 9, just to save time and not make as many dots. And then we are going to and then we'll just make a line, right? So, I mean, you'll use rulers. I use my kind of fake ruler here, but then you'll just put your ruler down and connect the dots. And we're just trying to figure out where the two graphs cross. So again, we're not taking an algebraic approach today. We're taking a graphical approach. So you can see that in this case, by the way, there are 3 possible things that can happen. Bless you. The line can cut through the V in 2 places, like it does here. The line could cut through in one place. It's very possible. Or the line could just miss the V altogether. So those are 3 possible situations. I didn't put any in today's lesson or assignment where the line just misses the V. I thought that would be pretty anticlimactic. But it is obviously a possibility. So our answer to this is just to name the points. And we're doing it again without any algebra stuff. It's just graphing. So what's the name of the first crossing point down here? This guy. Right. So one of our answers is 1, -2. And then we just name the other crossing point. What's this fellow over here? I believe it's 5, 2. And that's all you have to do. So I've got a few more examples. I tried to cover all different scenarios that you might encounter. So any questions on that first one? Just graph, see where they cross. It's just nothing to it. So second one, I'm going to do the other kind of warm-uppy one, I think. Let's do y equals -6 times the absolute value of x minus 1 plus 4. And then our second equation will be y equals -8. So I guess in just keeping with consistency, let's start with the top one first. So like you said, we got to find our home base. Where would we go to find the home base? Perfect. So we're going to write one up 1, 2, 3, 4 and put a dot. Oop. And then what are the slopes of the arms? They're going to be steep, right? The slopes are either 6 or -6. I mean, so the bottom line is I just understand that a slope of 6 is pretty significant. That means I'm going to go down 1, 2, 3, 4, 5, 6 for every one that I go out. That's what a slope of -6 means. And then I'm going to do it again. 1, 2, 3, 4, 5, 6, and then out 1. So that's just how you build it. And then as always, you put your ruler down and make the graph. Okay, so 1 down. Now we got to graph the other one, the one with the big green dots. Again, this is a pop quiz sort of from Algebra 1 days. What kind of a line is this when it only has a Y? Good memory. It's a horizontal line, right? Remember that there are special cases of lines. If you only see an X, it's vertical. If you only see a Y, it's horizontal. So this is not the kind of equation where we talk about slope or anything like that. It's very basic. It just means that we go down to where y is -8. So 1, 2, 3, 4, 5, 6, 7, 8, and then we just graph a horizontal line like that. So this is another distinct possibility is you could have an absolute value V or whatever you want to call that thing, and then a horizontal line that's going to either, I mean, again, this could do all 3 things, FYI. I could make it so it has no solution. I could make it so it has 1 solution, or I can make it so that it has 2 solutions. This one obviously has the 2. All right. So again, we're just going to identify and name the 2 crossing points. What are their names? I'm sorry, that's a little probably hard for you to count. I believe it's -1, -8. Left one down eight, I think. So -1 down eight, -8. And then the other one is that one I think is three. You got to go right three before you get in line. So I believe it's three, -8. Any questions so far? Pretty simple, right? Right. For these last couple, we're going to have to do a little bit of work. So for this first one, um, let's do this one first. Y equals the negative of the absolute value of x plus 3 and then plus 4. And then our second one is going to be x minus 3y equals -3. So let's, again, consistency, start with the top one, the red marked one. What do we do first? Perfect. Go to your build site. You're not worried about what you're building yet. You're just worried about how to get there, right? So now you're just following MapQuest or Google Maps or whatever. So we're going to go left 1, 2, 3, and then up 1, 2, 3, 4. We have a home base. And now we can throw away the directions to the build site and just get out the blueprint. And tell me about this graph. Yeah, it's just a standard 90-degree. I mean, its slopes are ones or negative ones. And again, you can mark every point along the way if you like, or you can just mark the rule with graphing. You've heard me say this in the other classes. You just have to graph as many points, excuse me, you have to graph points that are far apart, right? If that only means a few, as long as they're spaced, you're going to be fine. That's the key. Don't graph points that are right next to each other. Your lines will suck 9 times out of 10 because it'll start to go off course. So that's why you connect distant dots. And then we've got a little issue with the green one, but this is what we started class by talking about. I wanted to make sure that we were comfortable with this. So what are we going to do with that second one? Solve it. Move the x. Both good things to say. So we're going to leave the -3y. And what does that equal? Perfect. -x and then -3. And then we divide everything that we see by -3. And then we get our graphable equation. 1/3 plus 1. Good. And again, our training kicks in and we just know what to do. Like we now understand that we can just follow y equals mx plus b. So I'm going to start my journey on the y-axis always with y equals mx plus b. We start on the y-axis. So we're going to go up 1 and we can already see our first crossing point. And then the slope is up 1, right 3, up 1, right 3, up 1, right 3. Or conversely, down 1, left 3, down 1, left 3, down 1, left 3. And regardless of what you may perceive to be a formality, I still want you to actually graph the lines. Most people do that anyways, but sometimes people will just stop because they can see the crossing points. I get it, but we're still just graphing them. Okay, so make sure you have the full graphs there, and then we'll just identify the points. And so there's a crosser, and there's a crosser. What are their names? Sorry, again, making you count. 1, 2, 3, 4, 5, 6, 7, 8. Looks like left 9 and down 2. Okay, and then this one obviously is 0, 1. Any questions on that? Okay, got one more for you. I hope I put one in here that just crosses once. I'm hoping that that's what I wrote these last night, and I don't remember the answers. I used Desmos to help me construct them. And if I don't have one in there, I'll just, when you get to one on the assignment, just FYI. So like, if you don't know what I'm talking about, if you had a V, and maybe this will be the one, I don't know, that looks like this, and then you have a line that goes like this. Can you agree with the logic that this is the only possible crossing point? Because these lines, this arm of the absolute value is spacing away from the line. So there can never be another crossing point down here in space. We agree with that? So if this example is not that, I just want to make sure you understand that that's a possibility. Okay, they don't have to cross twice. It just happens that the first three did. So, all right, real quick, and then we'll be done. Our first one is y equals a third of the absolute value of just regular old boring x minus 2, and then x minus y equals -2. All right, let's take red guy first. Where do we go for the home base? Just down two. There's no sideways mover in there with the X, and so it's just a movement of down two. And what kind of build is this? Huh? I mean, maybe it was a dumb question. Like, where do I go to get more points? Is what I meant. Yeah, sorry, it's obviously a poorly phrased question. You guys are like, what are you talking about? Up one, out three. Just do that a few times on each side. Space them out, and then make your V. Good. And then this, I think, will be what I meant for the others, what I had insinuated I'd hoped it would be. So let's make sure. So we got to deal with the bottom one now, this guy here. I think, not everyone feels the same way about this. My take as an algebra guy is we can power play this and just make it quicker if we're just smart and we move the Y over there and the two over there, right? Algebra can be quick if you just don't make everything so hard. So like if I move the Y over here, it becomes positive. If I leave the X here, it stays positive. And if I move the two, it becomes positive. Just algebra can be quick. I want to say that again. So it doesn't have to be formal. Just jump things over the equal sign. Just remember to change the signs. Don't be a bonehead. So where would I start the green graph at? Up two. And what's his slope? One. So I'm going to just go up one, right one, a boatload of times. And I can do that conversely, like 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, 8. Just make a bunch of dots far apart is the key. And make a line. So this is what I had hoped it would be. Apparently, I'm not losing my mind completely. And you can see geometrically that they literally can only cross in the point that we can see. We don't have to make any future predictions. This red line and this green line are never going to reconverge. So the only crossing point is right there. And what's his name? -3, -1. So that concludes the lesson. There's about as short as I could make it. So I'm gonna hand out the assignment. You got about 30 minutes to get it done. 8 problems. Shouldn't take all that long. All right, let me know if you need any help. As always, I'll keep the recording alive, but paused.